Titration calculations. So the purpose of this lab is to determine the amount of liquid required to neutralize the hydrochloric acid in the Vice President's drink using the 0.500 concentrated sodium hydroxide solution. Our balanced equation was 1 mole of hydrochloric acid that reacts with 1 mole of sodium hydroxide to yield 1 mole of sodium chloride and 1 mole of water.
During the experimenting phase, we diluted 3 milliliters of hydrochloric acid with 97 milliliters of water to produce 100 milliliters of dilute acid, and we put in 2 drops of phenolphthalein as an indicator. Here we are neutralizing the dilute hydrochloric acid solution, aliquot, with sodium hydroxide, which is being dropped from a burette into the Erlenmeyer flask. When the solution turns pink, the acid and base are neutralized.
The purpose of the experiment portion of this lab was to discover how much base is needed to turn the acid pink. These values are recorded in the table. For all 3 trials, we started by setting molarity equal to moles over liters, then plugged in the molarity of the base, 0.500, and the number of liters taken from the table in to solve for moles. Step 2 states that the number of moles of base and the number of moles of acid are equal because of the 1-to-1 mole ratio derived from the chemical equation. Therefore, the number of moles of diluted acid are equal to the number of moles of base. For step 3, we use the molarity equation again. We set the moles of diluted solution equal to the number of moles of diluted acid over the number of liters of dilute solution. Finally, we use the dilution equation. We plug in the molarity we get from the last step as M2 and the number of liters we had as V2. We plugged in 0.003 liters as V1 because that was the amount of original acid we had. Then we solved for M1. Finally, we averaged the molarity we got from the 3 trials and came up with 0.045 concentration. In order to calculate how much liquid is needed to neutralize the acid in the vodka, you must average the 3 base amounts that we got, which are shown in the table, and we come up with 0.28 plus 0.22 plus 0.30 over 3 is equal to 0.27 milliliters, and that is how much base is needed to neutralize the acid.
Bum bum ba da da ba da 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 bum bum ba da 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 bum bum ba da 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 bum bum ba da 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 ba 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 da da ba ba da 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 ba 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 ba